In this presentation, we are going to discuss the magnitude of a vector, meaning the size, okay? The magnitude of a vector is obtained by applying the Pythagorean theorem, because bear in mind, a vector quantity, be it force or velocity, is represented by a line, okay, called a vector, a straight line with an arrow. And that line can be broken up into its component parts. Yes, the horizontal part and the vertical part. Okay. And as you can see, this creates a right angled triangle whereby the vector itself will constitute the hypotenuse because it is opposite to the 90 degrees. Here it is. The 90 degrees represented by a rectangle is always pointing towards the hypotenuse. And the legs form the 90 degrees. So the components, the horizontal and vertical, will form the legs, and they can be labeled as A and B. And C now, which is the universal letter for the hypotenuse, will be formed by the vector. And by calculating the length of the vector, you'll be will be calculating the size of the magnitude itself. So the Pythagorean theorem, as we know, is c squared is equal to a squared plus b squared, c being the hypotenuse, a and b are the legs. So therefore, c now would be the square root of a squared plus b squared. And as you can see, a is x2 minus x1, and b is y2 minus y1. So as seen in the above diagram, a right angled triangle can be formed with the vector c as the hypotenuse, and the legs are x2 minus x1 and y2 minus y1. I'm repeating what I just said. So consequently, the length of or the magnitude of vector GF can be calculated as follows. The size of GF represented by two vertical lines. So in vector language, when you put the vector itself between two vertical lines, this is the translation, the symbolic translation for the word magnitude. So you can read this by saying the magnitude of vector GF. Without the two vertical lines, you just have to see the vector GF. But once you see those two vertical lines and GF is between it, the magnitude of vector GF is equal to the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So let us apply this now to this vector. So we need to find what is x1 and y1, and we need to find what is x2 and y2. So as you can clearly see, x1 and y1 will form the constituent coordinates of the point G. That's the starting point. And it will be 2, 1. So x1 will be 2 and y1 will be 1. On the other hand, x2, y2 is the coordinates of point F. That's the end point. And that will be 9, 6 respectively. So x2 is 9 and y2 is 6. 9, 6. So now we have x1 and y1, x1, y2. We can calculate the length of this vector, which will give us the magnitude of vector GF. So let's substitute this into the formula. So in the place of y2, we substitute 6. And in place of y1, we substitute 1. And in place of x2, we substitute 9. x2 is 9. And in the place of x1, we substitute 2. And we do our calculations. 6 minus 1, that will give us 5. So we have 5 squared. And 9 subtract 2 will give us 7. So we have 7 squared. Let's continue the calculations. So 5 squared is 25. 7 squared is 49. And actually, you can actually do this automatically in your calculator, you know. Okay, but I'm just showing you how you can do this step by step. Now, 25 plus 49. As you can see, that will give us 74. So you got the square root of 74. 74 is not a square number. So you can write your answer in terms of decimals, but taking note as to how the question would like you to write your final answer. And the square root of 74 is 8.60. Round it off to 2 decimal places. So here's a demonstration as to how to calculate the magnitude of a vector by applying the Pythagorean theorem. So for vector exercise 7, obtain all the magnitudes or calculate the magnitudes of all, okay, of all the vectors in the above diagram. It was taken from a previous exercise and was not edited, but we'll edit it now. Calculate the magnitudes of all the vectors in this diagram here.